Hi, Mike Mays here. There's a new book called Math Hacks for Scratch, published by No Starch Press. It's all about how to use ideas in math to explore what Scratch can do, and how to use tricks in Scratch to get some insights into math. So I thought I would illustrate what's in that book by having a few videos to talk about some of the topics that are relevant to math and how it works with Scratch for you to explore, either with the book or on its own. So let's look at a Scratch screen and go there and explore a little bit about what Scratch can do. I thought the first topic would be about arithmetic. So arithmetic is all about combining numbers. Typically an operation of arithmetic, you take two numbers and you get one number out. And the usual ways to do that are operators in Scratch of addition and subtraction and multiplication, the star, and division with a slash. You could always make a little program and have Scratchcat tell you the answer on a stage. Let's set up a little program to do that, for instance. So go to events, and let's say when the flag is hooked, we will have Scratchcat say the answer to a arithmetic problem. So let's do a plus, and let's have it say whatever you want to add. Let's add up 2 and 3. So I'll put 2 here, and I'll put 3 here. And when I run this program now, the Scratchcat will say what the answer is there. Sure enough, it's 5. Now that's certainly a good way to do it, and we can use the stage, but actually the programming panel here in the middle has all that we need to do that work. Once we've got the operation 2 plus 3, we can just click on what the operation is, plus, and it will show that the answer is 5. So just exploring how Scratch does arithmetic, we can do it all in that middle panel. So not too surprising, you can combine two numbers and get a number out. What's kind of interesting is when you try to use Scratch to combine numbers that are officially not allowed. So for instance, you often hear you're not allowed to divide by 0, that's not an operation that's permitted in arithmetic. So if you try dividing by 0, say 1 divided by 0, then what does it say the answer is? Well, it says the answer is infinity. And that's a special notation in Scratch to report an answer that is large without bound. You can think about what's happening as a limiting case. When you divide 1 by a number that's closer and closer to 0, the answer gets bigger and bigger. Divide 1 by 1/10, and it's 1 divided by 1/10 is 1 times 10, that's 10. 1 divided by 1/100th is invert and multiply, it's 100 out. The closer you get to 0, the more zeros you put, decimal point 0.0001, the more zeros you put there, then the larger the reciprocal of that number is, so the larger the value is. So saying the answer is infinity is just a way of saying that as you get close to 0, it grows without bound. So that's what comes out. Now here's something that might be a little bit surprising. If you try it again and you use 1 and you divide by minus 0, well, that's silly. Minus 0 is 0, and yet with that minus in front, it is going to invoke the arithmetic of signed numbers. And when you divide a positive number by a negative number, what you get out is a negative number. And sure enough, the answer that Scratch reports for this combination is minus infinity. So there's another symbol that would arise. Now, infinity is not a number, but Scratch can work with infinity as though it were a number. For instance, if you wanted to add infinity, so it knows that 1 divided by minus 0 is minus infinity. Let's make it 1 divided by 0. So infinity, and you add 1 to that. Well, what's bigger than a number that's big without bound? Well, it's still big without bound, so the answer is still reported as infinity. Now, it would be nice if you could put infinity in here as a value to work with directly. So if you try to do that, it fails. The reason it fails is Scratch expects these operations to be on numbers. And if I try to start typing infinity in, it thinks infinity is a string, just a word, and it won't let me work with the word infinity. A trick to get around that is to set it up so that I have a variable whose value is infinity, and then I could plug that variable in. So let's set that up. So under variables, I'll put in a new variable, and I'll make a variable called infinity. There it shows up in the stage. I'll go ahead and do another one. I'll make a variable called minus infinity. Scratch is very generous in what it lets me name my variables. So some programming languages, I couldn't start a variable name with a dash, like that minus sign, but Scratch doesn't mind. And now the trick is to set infinity to be equal to that value that generated an infinite value in Scratch. Set infinity to be 1 over 0. And when I click on that, that will invoke that command, and watch what happens to where it shows for infinity. It will show that infinity is there, infinity. We'll do the same trick. Let's do another set. Set minus infinity to, well, we find it to be 1 divided by minus 0. And now when I click on that, there's minus infinity. And stuff works out. Okay, I can now do my little arithmetic test. I can't add the string infinity to 1, but now that I've got a variable called infinity, whose value is infinity, I can use that variable and add 1 to it, and out comes the answer of infinity. So the point is that Scratch has this number system, the numbers you're used to, and it extends it beyond that to be numbers that to be things that go into the number system that are kind of extra. That's this infinity and minus infinity, and that's what it will report for certain kinds of answers. When you get to we talked about in chapter 1 of the book, talking about the arithmetic of Scratch. There's a place where there's a largest possible number that Scratch can hold. Just the way it represents numbers internally, it can't be any bigger than that. And so if you do an operation that exceeds that, it will say the answer is infinity. It kind of gives up and says, okay, it's too big. So we've got these values that come out, and they're kind of interesting to see what happens. Now, something else that you might try is to think about other kinds of situations where numbers are somehow step outside the realm of what you're used to. So under this operators, there are functions that show up. So this operator gives you possible functions, and one that's kind of an interesting one is the square root. So think about taking a square root. The square root of a number is that's the value that you multiply it by itself to get the number back. And square root of a negative number, you can't multiply two real numbers and get a negative number out. So there would be no value that could be used. Now, if you know a little bit more math, you could start thinking about complex numbers, and the square root of minus 1 would be square root of minus 1 would be the value I, but Scratch doesn't know about complex numbers, so Scratch assigns a value square root of minus 1 to be this thing, NaN. That means not a number. It just doesn't work as a number. And we could do the same trick of thinking about not a number to start doing arithmetic on things that Scratch thinks aren't numbers by making a new variable. So let me go back to variables. I will make a variable called NaN that I want to remember that is not a number, and initial value of it is 0. So if I set not a number, NaN, to be this value that reports square root of minus 1, then when we click on this, it will run that, and out comes not a number for that. And now we can start seeing what kinds of things happen. Now, not a number is a possible outcome for Scratch. There's an odd thing in Scratch that I find kind of an odd thing. Suppose you have a situation where you've got not a number and you add not a number. So start with not a number, add not a number to that. What should be the answer? Well, I would think it would be not a number. Scratch says the answer is 0. Now, you can either believe that or not, but it's an interesting thing that what the Scratch universe is, the way it keeps track of its internal representation of some numbers. If you've done an operation in arithmetic and you end up with not a number as what the answer is, then somehow you can kind of get back to 0. So I'm wondering if somehow internally it's some kind of just a string representation. But whatever it is, out comes a value that's reported. Now you might think about this. Here's a little assignment that might be a fun thing to do. To think about, you make a times table, like you learn how to do the multiplication table by setting up all possible answers for one-digit numbers. So in the multiplication table, you'd find an entry for 6 times 7 and entries for 5 times 4, and always the ways you can come up with calculating products. So how about doing this? Come up with a little table, say a 3 by 3 table that would have the entries plus infinity, not a number, minus infinity, and look at operations of arithmetic and see what happens when you combine them to get something out. Just for instance, suppose we wanted to subtract infinity from infinity. Well, that's a situation where you might think the answer ought to be 0, because what you kind of imagine, okay, these two things would cancel out. So let's put in infinity minus infinity. The right way to think about infinity is like what I was talking about, the 1 over 0. You look at a limiting value. So infinity means a quantity that is growing without bound. And so you've got two infinities. They're both growing without bound. But if they're growing without bound at different rates, it could be that the difference also grows without bound. Or the difference could be 0. The difference could be any number. So infinity minus infinity is indeterminate. And Scratch knows that. Infinity minus infinity, it thinks it's not a number. So I agree with Scratch in that case, that it comes out to be that. How about infinity minus infinity? Well, minus and minus infinity, this is growing without bound. This is growing without bound. I bet this one's going to be infinity. So lots of fun to explore. You're doing kind of like arithmetic, but it's arithmetic on a set of numbers, or a set of things that act like numbers. They go into operations, but give extended values out. This is something that Scratch made some decisions about what's going to count as a number, what's going to count as combining these values, and it's kind of fun to explore and get behind the scenes a little bit and see what it's doing to do this representation. So, see what you think of this, and keep watch on this. I'll try to be posting more of these over the next few months to see where math makes Scratch do tricks that it might not know how to do otherwise, and where Scratch lets you see things about math that you might not have noticed otherwise. Great way to go back and forth. So, talk to you another day.